Weathering and erosion. So rocks exposed at Earth's surface are continuously being broken down. Now, weathering is a set of physical and chemical processes that break rocks into smaller pieces. So again, weathering breaks rocks into smaller pieces. Sediments are small pieces of rock that are moved and deposited by water, wind, glaciers, and gravity. And then sedimentary rocks are formed when sediments get glued together. And the formation of sedimentary rocks begins with weathering and erosion to produce sediments. So you can't produce sedimentary rocks unless you have sediments. So weathering. Weathering produces rock and mineral fragments called sediments. Sediments range in size from boulders to microscopic particles like clay and silt. Chemical weathering occurs when minerals in rocks are dissolved or otherwise chemically changed. So chemical weathering actually does change the mineral composition of the rock. In physical weathering, more resistant minerals break off of the rock as smaller fragments that are chemically unchanged. Rock fragments break off along fractures and grain boundaries. Okay, so again, chemical weathering changes the chemical composition. So there are different minerals involved once chemical weathering has occurred. Physical weathering does not change the chemical composition. It just breaks the minerals into smaller pieces. Weathering of granite. So if we have chunks of granite, like this is basically a chunk of granite, you have different grains in here. You have quartz grains, you have feldspar, etc. But when exposed to chemical and physical weathering, granite eventually breaks apart and might look like the decomposed granite shown here. Okay, so we have the granite shown over here. You have these common minerals in granite, which you have quartz, feldspar, and mica. Which of these might be more resistant to chemical weathering? Well, it looks like the quartz here would actually be more resistant to chemical weathering. The feldspar and the micas are actually breaking down here. Okay, but then what happens is once these minerals break down, well, they're holding a lot of this the other minerals together here, so they start to all fall apart. So once some of the minerals start to break down and change or dissolve, then the other minerals they're holding together also fall apart. Erosion. So erosion is the removal and transport of sediments. Okay, so weathering produces sediments. So weathering produces sediments, and then erosion moves those sediments. It removes them and transports them somewhere else. So agents of erosion include wind, moving water, gravity, and glaciers. Those are our four main agents of erosion. Visible examples of erosion are all around us. Streams become muddy after a storm due to silt and clay-sized particles being washed into it. A gust of wind picks up dust, including soil, etc. So there are these different examples of erosion that are happening all the time around us. Most materials are eroded downhill. Why? Because they are heavier. Okay, so most materials are heavier, or they're heavy, so they will erode downhill. The only thing that really can erode uphill would be very fine particles of dust, maybe small sand grains and stuff that might get blown up a sand dune or something like that. But wind may carry fine dust to higher elevations. Part of the reason most things go downhill as well is because moving water flows downhill, gravity pulls things down to the ground, and glaciers flow down. So really that's the other thing. A lot of things erode downhill because that's the way the agents are moving. So these agents here are actually moving downhill, except for the wind. The wind kind of goes sideways and up. And again, just our agents of erosion here. So you have wind creating a dust storm. You have moving water, so rivers, waterfalls that move sediments around. Gravity, so things like landslides. So if the soil gets too damp or whatever, there's an earthquake and the land slips, and you have a big chunk of the ground just slide down the hillside. And then glaciers are basically like rivers of ice. So this is basically formed from years of snowfall that then packs down and forms ice that then starts to flow. And glaciers will pick up boulders or anything and move them along with them. You actually see some dust and stuff on top here. So, but glaciers move all sorts of materials. And then deposition. So deposition occurs when transported sediments are deposited on the ground or sink to the bottom of a body of water. Okay, so the largest grains settle to the bottom, and then progressively finer grains settle on top. Why? Because the larger grains are heavier. They basically sink faster. They get pulled down by gravity, and they sink to the bottom first. Then the finer grain material can stay afloat longer, and it will eventually sink. But it sinks much slower. Sediments in nature are deposited when transport stops. So when whatever is transporting the material stops moving or has less energy, doesn't have enough energy to carry that size particle, then that material is deposited. Like big boulders, for example, could be moved by a fast flowing stream or flooding or something like that. But once that stream slows down, those boulders aren't going to be moved anymore. But other things, the wind stops blowing. So if the wind stops blowing, any dust that's in the air is going to start to settle down. Rivers enter a lake or ocean. So when a river hits a larger body of water, it slows down and spreads out. And you get basically what's called a river delta here. So this is the river slowing down as it hits the ocean and then starts dropping all this material. So a glacier melts at its terminus, and this is called a terminal moraine. So basically at the front edge of a glacier, such as our example up here, you end up with what's called a terminal moraine, which is where all this material is left at the end of a glacier. Energy and transporting agents. So fast-moving water can transport larger materials than slow-moving water. Kind of said that a second ago, talking about the boulders being moved by fast-flowing streams. But as water slows down, large particles settle out first, then progressively smaller particles. That's why you also get material dropping out of rivers when they flow into another body of water. When a river flows into a lake or the ocean, it slows down drastically, which allows a lot of these smaller particles to settle. Wind follows a similar pattern, but it can only move small particles. So the stronger the wind is blowing, the bigger the particles it can move. Sand dunes are commonly made of fine, well-sorted sand. So you have very fine, well-sorted sand in these sand dunes, bigger particles on the bottom, smaller particles on top. You can have material here eroding uphill, like you can have sand blown from the bottom of the sand dune, sort of up towards the top of the sand dune. Glaciers and landslides do not create sorted deposits. So a sorted deposit, again, is like you have your heavier material on the bottom, then you have progressively lighter material on top. So you get this layering effect. But glaciers and landslides do not create sorted deposits. Glaciers move all sediments with equal ease, and then landslides really move everything downhill in one big jumbled mass of material. So